Today, we're going to dive into a story where cutting-edge AI meets the absolute pressure cooker of an emergency room. It's all about teaching a machine to see what even the most trained human eyes can miss, and in the process, save lives.
And it all starts with this number, 6 million. That's roughly how many people die from traumatic injuries around the world every single year. It's a huge, staggering number that points to a massive global health crisis. You know, when a patient gets rushed into the ER, a CT scan is often that first critical step. It gives doctors a window, a look inside the body to find out what's wrong. But just getting the picture, that's only half the battle. Figuring out what it means, quickly and accurately, that's where the real life or death challenge begins.
And that challenge brings us to our first topic. We tend to think of epidemics as diseases, right? But traumatic injury, that's a hidden epidemic happening on a global scale. Just to put it in perspective, in the US, if you're under the age of 45, trauma is the single biggest threat to your life. So this isn't some far-off problem. It's a daily reality, and it puts an incredible amount of pressure on our emergency medical systems. So who's right in the middle of this pressure cooker? The radiologist. It's their job to look at these scans and make these unbelievably high-stakes calls in just minutes. But as you can imagine, it's a task that's filled with difficulty. And check out this quote from the source material. It's incredibly revealing. It says that diagnostic errors in trauma are common. Now, that's not a failure of the experts. It's really a testament to just how brutally difficult this job is. So what makes it so tough? Well, for one, a single trauma scan can have hundreds, sometimes thousands of images to review. On top of that, the injuries themselves can be incredibly subtle. We're talking a tiny tear or a small bleed. And finally, here's the real kicker. You can have two world-class experts look at the exact same scan and actually disagree on the diagnosis or how severe it is. And this is where the whole story takes a fascinating turn. If this task is so complex for humans, could artificial intelligence help out? The answer is a big yes, but there's a catch. An AI is only as good as its teacher. Now, the idea isn't to replace the radiologist, not at all. It's to give them an AI co-pilot, an algorithm that could help scan the images, maybe flag the most critical cases that need to be seen right now, or point out those subtle little things that might otherwise get missed. But there was a big problem. Previous AI models were pretty limited. They were usually trained on data from just one hospital, which made them biased and pretty unreliable anywhere else. They could often only spot one specific type of injury. The real goal was much, much bigger. Create a single, powerful AI that works in any hospital, anywhere in the world, and understands all the complexities of multiple injuries happening at once. And to do that, you need something called an annotated dataset. Just think of it like the ultimate textbook for an AI. It's not just a bunch of random images, it's a collection where human experts have gone through every single image and labeled everything. Every organ, every injury, every critical little detail. Which brings us to the breakthrough moment. A global team of researchers decided, you know what? We're going to build the exact textbook the world needs. They called it RATIC. Its purpose sounds simple, but it was incredibly ambitious. Create the largest, most diverse, and most carefully labeled dataset of abdominal trauma scans ever put together. And then give it away to the world, for free. And the scale of this project is just mind-blowing. We're talking about scans from over 4,000 patients. This data was collected from 23 different hospitals and centers across 14 countries. And that global diversity, that's the secret sauce. It ensures the AI learns from all different kinds of people and scanners, making it truly universal. This flowchart gives you a sense of the incredible work that went into this. Every single scan had to be de-identified to protect patient privacy, then uploaded, checked for quality, and only then could teams of experts begin the painstaking work of annotation, before it was all ready. Okay, so we keep using this word, annotation. But what does it actually mean for a radiologist to sit down and annotate a scan for an AI? Let's take a look. This is just a fantastic example. On the left, you see a regular CT scan. That little arrow is pointing to an injury on the spleen. But on the right, that's what the AI gets to study. The liver, spleen, kidneys, they've all been meticulously outlined and color-coded by an expert. This is literally the page from the textbook that the AI learns from. And who did all this incredibly detailed work? An absolute army of experts. The annotation team was made up of 45 specialists, abdominal radiologists, emergency radiologists, you name it, from 38 different institutions. And get this, Every single injury was reviewed by 3 separate radiologists, just to make sure it was as accurate as humanly possible. So, what's the result of all this work? Well, this massive global project wasn't just some academic exercise. No, it was designed from day one to directly change the future of emergency care for everyone. And here's the playbook for how they did it. First, they released the dataset for everyone to use. Then, they hosted a huge competition challenging the brightest minds in AI to build the best trauma-detecting models. And those new models are now paving the way for real-world tools that can actually improve patient care. And the response? It was absolutely overwhelming. 1,500 competitors from all over the world jumped into the challenge. That's 1,500 teams all working at the same time to push the boundaries of medical AI, all using this one incredible dataset. But really, the competition was just the beginning. By making this dataset completely free and public, the creators have basically provided the fuel for countless new AI innovations for years, maybe even decades to come. And that brings us right back to where we started. This whole project, all the data, the annotations, the competition, it's all building towards a future where every single ER has a co-pilot, an AI trained by the world's best doctors, ready to help save the next life that comes through those doors. The only question left is how many will it be?